everyone. Welcome to MOTEK 2012. I'm Roland Heitman from Synatec, and I'd like to give you an overview of how we can help improve your efficiency, save costs, improve your productivity, and improve your quality for operations using torque tool technology. What I'd like to show you here is a typical production area. This is a final assembly area for automobiles. We could be talking about any production area. The key element of the production would be torque tool technology. Here we have an environment. We have a schematic of 2 cells. We could easily add 200 cells. However, they realize that if they want to improve their productivity, efficiency, and quality, they start to add peripheral processes. Some processes include part documentation, where they want to store the part numbers, serial numbers, for example, of critical parts. Another thing they may want to do is they start to realize, hey, we could really use a pick-to-light shelf, make sure that we pick the proper parts. So what we see here what starts to become a very complex production environment. We may also want to track the parts coming down the production line. It starts to become a very complex production environment with a lot of infrastructure. Here we see many times as the customer implements this technology, they're using different vendors along with different infrastructure. Things aren't talking together very well, and we start to get a very expensive system, not only from installation standpoint, but from a maintenance standpoint, that doesn't really work optimally in a production environment. What we want to do is try to get all of this functionality without all the infrastructure that you see here. How do we bring all this together in one simplified system, yet realizing all the benefits to really help lower your costs and improve your quality and improve your productivity? With Synatec, we can provide you that system. That system is now a single information infrastructure, internet-based, and now each station on the production line is built up accordingly. So we can build it up. Again, we start with the core basis of torque tool technology. We normally have 1 or more torque tools in a station. We may have 2 in one station.
Can you have different torque tool manufacturers?
Yes, of course. With our system, we have an open architecture with modular design. So we can integrate anyone's torque tool technology into our infrastructure. We integrate Atlas Copco, which is one of the largest manufacturers, but we can integrate a system of multiple manufacturers. And I can show you an example of that here. Here's our modular technology, which is the core of our software, our module server, line browser module server. Our module server is built up of different modules that come in to bring all these features into play. Here we have all of the different torque tools. We have modules written for every torque tool to be able to instruct the tool which program to run and be able to pull the data out of the tool to validate torque. All the torque parameters were done correctly. First thing we may want to put in is a worker authorization. We want to make sure that the right worker is doing the job, that it's properly trained for that task. So we can integrate worker identification into that cell. We talked about pick-to-light before, and we can integrate a pick-to-light cell in the station. A pick-to-light cell may have a similar functionality we showed here. Here's an example of Volkswagen Emden, where we have now a very large variety of parts used in this one cell. We now instruct the operator with the worker guidance and the racks which parts need to be picked for that particular assembly. She picks those parts and identifies with the shelf that she has picked that part, continues until all the proper parts are picked, and now she can continue in the process. There's different sensors available for the pick-to-light racks, which are more automated, where all you have to do is pick, it knows that you picked a part, and you can continue as well. Another feature we have is the visual inspection, as I mentioned earlier. So visual inspection is a quality control capability that we put in place to make sure your process is properly implemented. Here we have an example of a visual inspection station in Emden, where we are checking the brake disc versus the engine. We do a serial number check on the part. We check the brake, whether the proper brake disc has been implemented. It's very critical that the right brake disc is correlated with the right engine. In the past, they've had process failures here, so we implemented this, and now we have 0 defects coming out of that process. So now we have these cells. These cells are a graphical representation of what really exists on the production floor. We can build them up in our software just about as easily as I build them up here. We have a very flexible configuration tool which allows you to configure this with drag and drop capability. A few simple parameters are programmed. You don't need a software engineer to put this system in place. You can very easily define the line offline and therefore implement it online very quickly and easily. We often have our customers doing that by themselves. What I'd like to show you here a little now is the data flow. How does this all work together? Sounds great. Look, we've eliminated a lot of the complexity. How does it work? What I'd like to show you is the data flow. The data comes from the customer server. Customer server gives us the orders, what needs to be produced in what order on the production floor. That's sent to the Synatec server. The Synatec server now breaks that down into executables so that we define exactly what work needs to be done in each station. And that work is then done by the workers in the proper sequence with all the proper error proofing in place defined by your strategy earlier. Again, worker identification, pick-to-light shelves, torquing, visual inspection, as well as part identification. All those things are instructed here. The worker then goes through his process flow. See the guys working away? And now 2 very important things happen. One is we automatically in our software have the possibility of setting up rework stations. The work defined by these rework stations is calculated automatically by the software, such that all work that is done in each station, we know exactly what was done properly or where we had a failure. Any failures are passed down to the rework station, where the worker is now very clearly instructed by our system in order to complete the work and correct any failures offline. The second important thing that happens is now, once all the work has been done in station, we've collected all the data, again, in a unified database now. All the data for all those processes are brought into one place. We send that back up to the Synatec server for storage and retrieval later. The data goes back. We then also, from the rework station, send the data back to the Synatec server, and then all the data is stored in the customer's quality system for future reference and data analysis. A very important thing is that when we do rework, we actually don't overwrite the failures from this process that are handed down here and corrected. We actually store all that data in the one database so we can have a complete record of what was done by who and when. So we'll go back to our production line again. You can easily build up this production line. Now another big benefit of our system, because we have such an easy configuration system, we know that our customers have configuration changes on the production floor all the time. You can very easily, if you decide that this workstation is overloaded with work and want to move one of these torque tools to a different station, it's as easy as removing that torque tool, bringing it to the next station, changing it in your configurator, and you're up and running. The other thing you can do is you can reprogram this offline. You're not doing it on the production line. So you can actually, even over a lunch break or a small break, move tools, send down a new program, and start running again. So it's a very flexible, easy to use system. The result is, as you can see here, there's much less infrastructure, so much lower cost. We now error-proof the entire cell instead of just monitoring torque tool technology. So we're helping you reduce errors, improve your quality, and we have all of this information in a single database. So when something does go wrong, it's much easier to find that problem much more quickly. We have customers where in their production line today, they may have 4, 5, 6 databases that if something goes wrong in a cell, they actually have to go to 4 or 5 different places, start looking at the data to see if they can make sense of what's going on. We can have that all in one single place, so we can determine the defects much faster, much quicker, and that saves a lot of money.
What would happen if my network went down or the server went down? That happens in our facility.
In the case where a network goes down, the nice thing about our system also, because we have a PC in each station, oftentimes with worker guidance, the PC stores a buffer of work orders. So we can actually have a whole shift worth of work orders in line, here at the station that can be run even if the network is down. Any data we collect can be buffered, and then once the network is back up, we send it back to the server for recording in the database.
Great.
So with that, I'd like to conclude. Thank you very much for your time and interest. We'd like to invite you into the booth for some further discussions if you want to know more about our system. We have some very nice stations set up that show all of this in reality, and we'd appreciate the opportunity to speak with you further. Thank you very much.